apagar el proyector. Es este.
¿Podría ubicarse esto?
Ah. ¿Ah?
Sí, por la cuenta de... Sí, por YouTube.
No.
Ça sera transmis par...
Ah,
Bonjour.
bonjour.
Ça sera transmis par le chaîne France TV.
I don't trust you. No, no creo. No, no te creo.
Mais du coup, il est version des France TV, France espagnole maintenant.
Yeah, sí, sí, sí. No. Oh, bonjour. ¿Cómo está?
Presente. Buenas tardes. Bueno, esta es una reunión de parte del grupo G, ¿no? Ok, tenemos el placer de tener acá al profesor Jean-Bernard Bayón, que aceptó gratamente dar una charla hoy día a ustedes. El título suena bastante llamativo. Bueno, pues esperemos que puedan disfrutar de esta charla. Gracias, merci. Jean-Bernard.
Ok, je vais, je vais ici. Ah, I forget. I have to speak in English because my Spanish is menos que más. Okay, so today I want to present you something which arrived to me when I was teaching in my university in Lyon. So I will begin, it is a story. So I will begin to say, okay, for the final examination, I have used to have a matrix, a matrix which is not difficult to see, and the matrix is the following: is 1, 0, 0, 0. Here is 2 over 1, that is a line 2. 2 to the power 2 divided by 1, so it's 0, 0, 0. And the third one is 3 over 2, over 1, 3 over 2, 1, 0, 0, 0, and so on, up to n over 1, and arrive to 1. So think about this matrix. So this matrix is a way in the final examination, I use for example this matrix, and for this matrix I ask to inverse this matrix. So to inverse this matrix is quite easy. For the student is maybe not so easy, but it's not so difficult to inverse this matrix. And when we inverse this matrix, we found, because it is inversible, because it is a triangular matrix with 0, 0, 0. So what we have to find is on the diagonal is 1, 1, 1, and here is minus 1/2 minus 2/3 and 0 here. If I continue, so instead to ask this one, so yes, is 1. So instead to get, so I want to inverse this one. So for this one is just to say 1, 0, minus 3/4, 1, and 0, 0, 0. So you can see when we inverse this matrix, what is maybe a schedule. And the schedule is, yes, and it should be something like that. 0, 0, and here is minus, if it is n here, is n minus, is minus 1, yes, is this value. And here is 1, 1, 1. Oh. And to prove that is not so difficult for the student. And what we have to, what we ask them is to add the coefficient of the inverse. When we add the coefficient from the inverse, that means in fact is 1 minus, is minus 1 over that, is 1 minus 1/3 minus 1, and so on. So minus 1 is cancelled, minus 1 is cancelled, here is cancelled, and here is cancelled. So when we make the summation of all the coefficients, we get something like, if I have not wrong, 1, because there is 1 here, minus 1/2, minus 1/3, minus and so on, minus 1 over n, and that is more or less equivalent to the logarithm of n. So I decided, well, it is boring to make always the same matrix for the final examination. It's very boring. So I decided not to have this matrix, but to have just a little bit different. Just a little bit different. And what I say, well, I can maybe take the truncation. So I take the truncation. Okay, it's just a little bit different. Just I take the truncation. I say, well, can we inverse this matrix? Okay, I say, well, that is easy to say this matrix is invertible because it is a triangular matrix. And after that, I say, well, okay, that is easy. And can we find something here? And why not the summation of all the coefficients? So after 15 minutes, I say if I cannot solve in 15 minutes, the student cannot solve it. After 15 minutes, I say I cannot solve it. So I say, well, I have to come back to the old matrix and to make the same thing. I was amusing because I say, well, I have to solve it anyway, to inverse this matrix and to make the summation. Inverse this matrix and to make the summation. So I use a computer. It's more easier to use computer to see what is the pattern. Okay, if you use a computer, okay, what I found is something like that. So it's something like that. I don't remember exactly what I found, but it's something like that. It's 1, 1, 1 here, 1 here, and here is either 0 either 1 or -1, or either 2 or either -2. So there is plenty of 0, plenty of 1, plenty of -1, plenty of 2, plenty of -2. Okay, but the pattern is quite, I don't see the pattern exactly because it was pretty strange, the pattern. And okay, I was here because I take this matrix with R, and I want to inverse, so R minus 1, and here it is a coefficient. Okay, okay, and this matrix is quite important. Did you remember the title of the talk? How to become rich and famous. It is this matrix, which is the inverse of this matrix. So this matrix, you may become rich and famous. You may. How? That is the question. So the question is, I will put that in red to be sure everybody wants. So I make the computation. So if you can make the computation, okay. And I ask you the question. Okay, absolute value because it can be negative. And that is a question. Can you find C such that the summation here is less than C, the square root of n? N is the dimension of the square matrix. Well, if you solve that, either you tell me and I get $1 million because that implies, if you solve that, if you solve this equation, you may get, you get $1 million. And you be very famous. Now, I will tell you why. Because, okay, it's strange, but it's possible. But think about the previous matrix. We know for the previous matrix, when we make the summation for the previous matrix, M, I don't remember. Okay, for the previous matrix is log n. And for this matrix, we don't know, but it's pretty close to the previous matrix. Okay, I will tell you, okay, if you found these inequalities, you get $1 million. That is correct, but maybe it's false. Maybe it's false. So that is false. The square root of n is false. So if I could, that is maybe false also. What is, you cannot, for the reverse case, it is not exactly the same thing. To get $1 million, so in one direction is true, but the other one, that means, oh, I prove is false. You get nothing. But for the converse, it's just a little bit different. I will put here is the same thing, but we have to change a little bit for the reverse case. Is that. So if you prove this one, you get $1 million US. But if you prove that is false for any epsilon, you get also $1 million. So here is the converse. That means to get $1 million, you have to prove that. Or to disprove. To prove or to disprove. Why is famous? Because there is a foundation. This foundation is, the name of this foundation is the Clay Foundation. This foundation, and this foundation say, if you solve this problem or an equivalent problem, you will get $1 million. It is the foundation of Clay. So you have to go to say, I solved the problem, so give me back $1 million. So why is very famous problem? Because it's related to one of the problem, is equivalent to one of the problem. And the equivalence is a Riemann hypothesis. So if you look on the web, Riemann hypothesis is a very old problem about this year. So it's quite a pretty old problem. So if you solve the Riemann hypothesis, well, but solving Riemann hypothesis is exactly the same thing than to solve that. Exactly the same thing. No less, no more. Is an equivalent, and maybe it is more easier to solve that. I don't know. And what means a Riemann hypothesis? So there is a function. We call this function the zeta function. That is a Greek letter, zeta. And this function is defined by 1 plus 1 over 2 to the power s plus and so on, plus 1 over n to the power s plus and so on. So this function is related, this function is a zeta function. And s, in some sense, is a complex number. So this function is pretty well defined for the real part of s is greater than 1. So, okay, you have to trust me a little bit. So for this function is just to say, well, zeta of s is that, and what? Why? Okay, why that and that is completely different function. It's completely different meaning. That is a matrix, and that is a complex analytic function. Okay, I will tell you what is the connection. And what means the Riemann hypothesis? This function is well defined on that is 0, that is 1, and is well defined here. Well defined. Sometimes I forget the spelling of the word. Okay, so it's well defined on the right part of this region. And because it is analytic function, we can define everywhere here. There is only one exception, is not here, the function is plus infinity, but everywhere we can push. And Breimann found on this line, there is the zero of the function. There is also zero here, but we know here the zero of the function, the Riemann, but here we don't know exactly. And Riemann say, well, it seems that all the non-trivial zero of this function belong to this part. Well, and it's strange. If we can prove that, that proves that. It's quite strange, but it is not so strange anyway, because when I want to inverse this function, it's quite easy. Not that, okay. If I want to inverse, I don't want to erase that. Okay. If I want to inverse this matrix, that means if I want to inverse this matrix, I will put here 1 over S. And I want to compute. So if I want to compute the coefficient, is this, so try to find what is the value of this coefficient. So I think, oh, it's not so difficult. So I put 1 over S times zeta of S. It's just to say the summation with respect to n and to m. So it is 1 n m to the power s. I want that is equal to 1. And to get 1, that means when I make the, and here, if I say that is k, so is the summation with respect to k of 1 over k to the power s, the summation with the product nm equal k of mu n, this summation, and I want that is 1. So to get 1, that means mu of 1 has to be 1, because it is 1 over 1. And for the other way, the summation nm is equal k, k different of 1 of mu n has to be null. So it is not so difficult to compute this value. And now, what is if that is not null? It can be null, but if if zeta of s is null, that means 1 over 0 is infinite. So if we can have the summation of that, if it is well defined, that means it cannot be null. So if it is not null, it cannot be infinite, and therefore that cannot be null. If it is, we can make the sum of that, that cannot be null. Okay. Okay. But now, by a strange thing, very strange thing, this value is equal to the summation of n equal of g equal 1 to n of mu g. So when I want to compute that, that is exactly the same thing than the summation of this function, we call this function Moebius. This Moebius function. When we want to compute that, is exactly this function. Okay, now if this, and I will show you why, if this function works, if this function, if the summation of the Moebius function from 1 to n is less than a square root of n, that imply 1 over 1/2 plus 1/2 plus epsilon plus I think you know how to prove that. That is not so difficult. Why? Because when I want to compute this summation, G from 1 to infinity of G to the power S, what I do? I can make something like that. If I call this function sigma of n, so that is just the summation of sigma of G minus sigma of G minus 1 over G to the power S. It's exactly the same thing. So when I take the first one, the sigma G to the power G of S minus the summation of G sigma G minus 1 over G over S. So that is sigma of G plus 1 over S. Is exactly the same thing. And therefore, that is equal to the summation of sigma G over 1 over GS minus 1 over G plus 1 S. And if that is less than a square root of n of G, so 1 over is less or equal the square root of G. And here, okay, the difference. And the difference is, we can see it is just G S, so is we have to make the real part of S plus 1. There is maybe there is C prime. So when this series is converging, this series is converging when the real part of S plus 1 minus 1 is greater than 1. So just we have to get the real part of S is greater than 1/2. So this series is converging for any real part of S strictly more than 1/2. And therefore, there is no 0. And therefore, the 0 has to be on this line. It's quite strange. Okay, but nobody proves that. And it is equivalent to for the problem. If we can prove that is less than this quantity, that imply, you can see why, the Riemann hypothesis. And the Riemann hypothesis is equivalent to that. So if you solve it, you will become very rich. No, maybe not very rich, but you will become famous in all the world. That I am sure. Okay, so this is the conclusion. Be rich and famous.
A veces el público ahí en la...
Ah.
Are there any other equivalents?
Oh, there's plenty of equivalents. Plenty, plenty, plenty. I don't know. This one, I think it is the most simplest one. But there is plenty of other equivalents. Plenty.
Maybe the proof that is the simplest way to prove.
Yeah, it is. I don't. I. The simplest way to prove it, maybe not.
Okay.
Maybe not. But it is the simplest way to present something which is equivalent to Riemann hypothesis. Riemann hypothesis is quite pretty hard because this function is an analytic function. And for the analytic function, I just present just a little thing. But it is why Riemann think about this line and so on and so on. It is important because what I prove is just to say, well, the zero is just on. If that is true, the zero it is on this line. Okay, but why there is not other zero in for real part of S strictly less than 1/2? So I don't present you this, but it has to be symmetric. Why there has to be symmetric? There is plenty of reason to do that. But it's just a little bit. But if you prove that, okay. But I don't think it is a. I will say, well, it is a good thing. I try, but I forget it. But it's quite pretty. It's similar to the matrix I give to the final exam. That is strange. For the final exam, the matrix is quite easy to make all the answer. I quote easy. Maybe not for the student, but for me it was easy. But for this one, I was discouraged to make something. But it take about, for me, it take about 15 days. Yeah, 15 days to solve the problem, to make the equivalence. So that means it's not so easy.
Thank you very much. The $1 million
See,
was published in all university.
no, it is not at the university. It's a foundation. It is a Clay Foundation. I don't know which university or the Clay Foundation were, but this is Clay Foundation, not a university. So look on the web. You have everything. You look Clay Foundation and you find everything you want.
So, can you get an explicit expression for the S?
Ah yes, we can get. That is the result I give you is related to the Möbius function. And when we add, gracias. And when we add, we can see, yes, it is exactly that. So when you want to solve what is the inverse, the coefficient is related to that.
Sorry?
The coefficient is related to that. I don't remember exactly, but for us, we don't need it. But you can find it. It's not 15 days to find it, so it's not so easy.
Yeah.
Okay.
Okay, question?
Oh, just to tell you what is important. If you have the Moebius function, I think that is true. N over G. I don't remember if it is 1 or 0, but and it is related to that. No, it is 1 or 0. It is 1 if Gn equal 1 and 0 is 1. So once you use this property of the Moebius function, you can find what is the inverse. Okay. Ah.
What's the relation with the end that you get there about the dimension of the matrix and what is its equivalence in the Riemann hypothesis?
The equivalence with Riemann, the real equivalence is that. That means if you compute this value, if the Riemann hypothesis is true, that implies for any epsilon, you can find C epsilon such that you have these inequalities.
Oh, but I mean that what's the relation between the dimension of the matrix?
The n is the dimension of the matrix.
What's the relation? It has any relation with about that dimension? Has any relation with the Riemann?
Here, if I put n, it is here. It is a summation of mu g from 1 to n. This summation is exactly the same thing. When I make the summation, I found that. Okay, to get it's possible to get it, but maybe it is not as possible because if you use this relation, you may get. But maybe you find a way to. Sometimes easy thinking is a good thinking, and usually the young people have a bad idea, which is good. Because people like me, I say, oh no, it's not possible. But the young people say, oh, I don't care. It should be possible. And sometimes that works well.
Agradecemos bastante, profesor. Gracias. Esperamos
Gracias.
más bien puedan haber más, millones. Sí, básicamente.
Más Patrices.
Eso estábamos, antes estábamos consultando, estábamos viendo, vimos que su asesor es Braces.
Sí. Braces. Unfortunately, now Braces was.
O sea, y sí, de ahí con Juan estábamos comentando justo y de ahí vimos que viene como del grupo Urbano. Entonces,
grupo it's become more and more important. I will be glad.
Entonces, es bastante curioso, ¿no? Porque no está tan lejos, o sea, de lo que nosotros pensamos. Básicamente estás por ahí, ¿no? Claro, toca ponerse a la par, ¿no? Porque son gigantes de la matemática, titanes, pero sí, o sea, no podemos decir que nos encontramos tan lejos, ¿no? O sea, es básicamente una cuestión de esfuerzo y motivación, ¿no? Como alguna vez me dijeron, si no eres muy bueno es que no le estás dedicando suficiente tiempo, ¿no? Entonces es curioso.
Hay una demanda grande de matemáticas. Eso tampoco se informa, ¿no? En el mundo hay una necesidad enorme. La matemática a un nivel razonablemente bueno. Está en una muy buena carrera. Ahora, referente a este evento, que bueno, la universidad bastante gana. Se podría invitar, no sé si hay la posibilidad de hacer charlas virtuales. Claro que sí. Se podrían invitar colegas de afuera, ¿no? No necesariamente restringir del país, que también del lado.
Tenemos una iniciativa, mañana tenemos a otros mexicanos y si no, nos gustaría que los profesores que también son matemáticas conozcan algún otro profesor.
¿De acuerdo? Sí. No necesariamente en español.
No,
Veo de que se adapta mucho.
Es un problema de hablar español. Especial matemático. La palabra es importante en matemático.
También recordarles, bueno, en sí ha salido como un imprevisto porque realmente era otro el expositor, ha tenido un percance, el profesor Renato Benassi. De todas maneras, la próxima semana esperemos no pase ningún otro percance. Y no, bueno, traeremos otro expositor, ¿no? Por ahí de otro rango. Entonces, por ahí tal vez nuestro amigo Paucar nos consiga un expositor así, pues. Entonces, sí, los esperamos básicamente, el profesor Benassi, esperamos bastantes personas. Si tienen algún libro por ahí, me estaban consultando, por favor que sea original, no lo conocemos, así que no sabemos cómo reaccionar. Hay algunas personas que sí, pero es un trabajo matemático. De todas maneras, sí van a verlo bastante de referencia, ¿no? El profesor Benassi sí ha sido, creo, referente para bastante. Se ha dedicado a la docencia más que a la investigación, pero es bastante referente para una generación completa. Así que los esperamos. Agradecemos a profesor. Gracias. Esperamos
gracias,
vuelva a tener
gracias a tú.
Okay. Y esperamos. Gracias con todos. Nuestras puertas están abiertas. Tenemos nuestra aula en el sótano. Si desean pueden bajar, informarse de nuestras charlas. También